Hello, math champions. You would have seen questions like these, and where you would have been asked to change the subject to write an equation for x is equal to given by like this, like y is equal to root of ax, y is equal to x square plus b. And here's where you see that you are confused a lot and how to do it, right? Now, why, first of all, why do we have to learn this? What is the necessity of doing all these things? Is First of all, you learn something called manipulation skill, right? Maths is not just about numbers. Maths is about analysis. How do you can analyze something? And maths is also about how you can manipulate something. Means a certain thing is given. How you can change it to look at a different way. If I have to tell you what is a manipulation in simple terms, see for example, 16 can be written as 8 times 2. Okay. 16 can be written as 4 square. Also, some you can also write 16 is equal to um, 9 plus 7. Okay. Now, why? Because why we are doing in different ways? Because 9 is a perfect square plus something. Or you can write just 16 as a only perfect square also. Or sometimes you might require to use 16 as a product of two factors. So depending on the situation, the same 16 can take different forms. This skill of changing one thing into various different things according to what you require is a skill that will be required for you to solve problems in your own life. So when you're solving all these algebraic equations, don't think it is not connected to your life or you will not be using it. You may not be using the x and y directly, but the skill that you're developing, you will be using in your life to solve problems. Because based on what you want in life, you will have to change your situations, change your conditions like that. Isn't it? You all agree that. So that is the reason how algebra prepares you for life. So when you understand this, when you understand that manipulation skill is what I'm learning here and that skill is what is required. You might not use algebra directly in your daily life, but this skill you cannot develop without using algebra. That is why algebra is the mother of mathematics. Like it's a very important thing in mathematics because we may or may not use numbers in our life every time, but we use all these skills, analysis skills, manipulation skill. Okay. So this is how the application of these kind of problems is there in your life directly. Now, how to do these manipulation? Okay. For that to understand, you'll have to understand three things. Okay. Um, you'll have to maintain the balance of the equation because it's an equation. Okay. It's equal to sign is there. Equal to sign is there and you have to maintain the balance. What do you mean by maintaining the balance? Means, for example, you have something on one side of a weighing balance, another thing on a weighing balance. Now, if you're balancing this, okay, when you're balancing this, let's say this is one part of the equation y, another part is x square plus b. They are saying equal to. That means this left side of the equal to sign and the right side of the equal to sign are equal. They're balanced. Now, how do we maintain the balance? How do we maintain, whatever we do, we should maintain the balance. So whenever you're looking at the equation, look at it as a weighing balance. For example, if you are just dividing this side by b, how will you maintain the balance? If you are doing something on the left side, you have to do the same thing on the right side also so that it will maintain the balance. Otherwise, the balance will go topsy-turvy. If you do a certain thing on only one side, the balance is gone. So equation is no more correct, right? It's very important to maintain the balance. That's the first thing you remember in terms of manipulation in algebraic equations. Then the second thing that you have to remember is you'll have to maintain connection between the steps. That means to say, if I have something like, for example, x is equal to 4 times x plus 4, like this. If I'm having this kind of a thing, and if I'm writing 4x plus 4 this side, and I'm writing x. Now, next step, I'm writing this one. There should be a connection between from this step, I'll have to go back and get this step. Do I get it? That's the question. Now, if I say, out of this right side things, I take 4 as common factor. If I take 4 as a common factor, what am I left with? X. And what am I left in this term? 4 times 1. So, am I getting this? No, I am not getting. So, that means I am wrong at this step. So, how do you check whether you're doing every step correct is by seeing whether you are able to connect back to the previous step. If you're not able to connect back to the previous step, that means you've done some mistake in that particular step. Simple. That's all. So you have to maintain the connection between the steps. That means if a particular next step is coming from the previous step, from this, you will have to get this back by doing something else. Like what do we do from this first step to the second step? From the first step to the second step, we did the multiplication. Multiplied this with this, correct? That's what we did. What is the other way? From here, if I'm factorizing, I should get this. Because opposite of multiplication, right? Like when you multiply the factors, that is when you get the multiplication answer product, right? So for example, 4 and 5 is multiplied to get a 20, means 20 is the product. Okay, 20 is the product, 4 and 5 are the factors. So these kind of basic concepts you should know, so that if I am getting a product from factors, that means I should get the factors from the product also. And that process is called factorization. You can watch my other videos in the channel to understand what is factorization. Okay. So basically the connection between steps should be there. That's the second thing that you have to notice or keep in mind. And the next thing is, whenever you want to maintain the balance or see the connection, you will have to nullify the effect by opposite operation. What do you mean by this? First of all, many students, they would have gone through mathematics for so many years, but they wouldn't have understood the words like operation and things like that. Okay. What is an operation? Operation means addition, subtraction, multiplication, division, squaring, right? Square root, all these things. The things we do with the numbers. For example, with 4 and 5, I can add them. So adding is called as an operation. With 4 and 5, I can do the multiplication. Multiplication is called as an operation. Like these different operations are there. Okay. Squaring is an operation. That means if I have a 4, squaring it means 4 times 4 I am doing it. Cubing means I'm 4 times 4 times 4 I'm doing. So these are the operations. Okay. Now, we have to know the opposite operations. Means what? Whenever I'm adding, okay, how can I reverse the operation? Right? Operation adding means bringing things together. What is the opposite operation? Means what is the reverse operation? Subtraction. Right? If I'm multiplying two things, okay, what is the reverse operation? It is a division. If I'm squaring two things, squaring it, what is the opposite operation? Square root, taking the square root of it, that's the opposite operation, right? Now, these are, now if I'm raising a particular thing to a certain power, okay, let's say power to the power of a. What is the opposite operation? Opposite operation is you are taking the root of that power, that power root you are taking. So these are the opposite operations. So when we are doing a certain thing, like we're having addition, if you want to remove the addition, then to nullify that addition, we have to choose to do subtraction. When you want to nullify, we want to remove the multiplication, then we do the division. So these are the three things, according to me, you have to know to manipulate algebraic equations. Now with this basic, now we will go and see how to solve all those problems. If you see all these problems, if you're not careful, you might get all these same answers, but all of them will have different manipulation. What are we trying to do here is as of now, everything is saying y is equal to y is equal to y is equal to. Now, in the end, we are going to get x is equal to. That's the final point. We are going to change it, change the look of it. It looks like this, y is equal to, we are going to change the look of it as x is equal to. That's the meaning. Manipulation is changing the look of it. Okay, so what do I do? For that, we have to see what is the outermost operation. If you see, what is the outermost operation? There are two operations here in this case. What are the two operations? One is a square root. Another is a multiplication between a and x. The two operations here. First, we'll have to nullify the outermost operation, right? Outermost operation means the square root is after the multiplication. See, can you see here? Multiplication is inside and the square root is after that multiplication. So you have to nullify that first. How do we nullify it? The opposite operation of a square root is squaring. That means you're going to square on both the sides. If I'm squaring on one side, I'm getting y. If I'm squaring, I get y square. And if I am squaring this also, okay, what happens? When I'm nullifying the effect, I will get it as square root of a square, right? Square of a square root means the original number you will get, right? So y square is equal to ax you're going to get. Now the next operation is what? Here it's a multiplication. What is the opposite operation? It is division. So what am I to divide? I need only the x on one side. So I don't want that a. So I'm going to divide that a. So I'm going to divide the a on this side also and this side also. If you see here, I'm balancing by doing it on both the sides. I'm maintaining the balance. If I'm not doing the division by on one side, it's going to be wrong. So what is happening? I'm dividing the a on both the sides. So I'm getting y square by a is equal to x. See, we changed or manipulated this equation from looking as from y is equal to x is equal to, I have got it. Right? This is a way we have manipulated. Now let's see the next equation. Again here, what is the outermost operation? First, what is happening here? A is multiplied by a x square and added to b. Correct? Now added to b. Now what is the outermost? What is the final operation that is being done? Is it the square? No. So it is the addition that is being done and finally. So outermost operation is addition. What is the opposite of that? Subtraction. So what do we want to remove? We want to remove the b. Why? Because we want to isolate the x. Remember that. We want to isolate the x. We want to separate the x. So first we'll have to remove the b. That means opposite of addition will be subtraction. So I subtract on both the sides. What am I going to subtract? I'm going to subtract b. Okay. So what happens is this side also I'm subtracting b. Now many children would have learned this like b comes to the left side, comes to the right side, and there's a problem with that, right? That kind of understanding. It's not the problem with the teachers teaching it. It is right. But then children understand, students understand it as if it is coming. No, it is not actually coming. It is not actually coming. What I'm trying to do is b is added. I don't want the b. I want to nullify that b. So I'm actually subtracting on both the sides. If you see the essential effect is b plus b minus b, this becomes a 0, right? And only the minus b on the left side is remaining. So students think b is coming to the left side. B is not coming anywhere. We are trying to nullify the effect of it. Okay. So what are we remaining with? Y minus b is equal to a into x square. Now what is the next operation? Is it the square operation or is it the multiplication operation? Now, for you to understand this, understand what is very close to a. What is very close to x? Is it the a or the square? Very much attached to x. It is a square. That means it is inside, which is very much near. So the outer operation here again is a. And a is multiplied here. The operation is multiplication. So now I want to remove this multiplication. So what will I do? I will do the division. So y minus b by a. Now, why many students now make a mistake in this place? They write as y by a minus b. Now, why is this wrong? Why is this wrong? Is because now a is divided means it should be divided for the entire thing, correct? On the entire left side and the entire right side. That is how we can do it. Because again, balance has to be maintained. Like for example, this side something is there, subtraction, and here multiplication is there. Means if I have to divide, is it fair that I'm dividing only for the y? No. We'll have to divide it with for the from the b also. Okay. So when we are dividing, it comes for the entire y minus b. You can write as like this separately also you can write. Okay. That way also you're dividing the A from Y also and B also, that is okay. Or you can also write it simply that Y minus B by total A. Why? We know by fractions. I'm just writing it here. We know that 1 by 4 minus 2 by 4 is same as 1 minus 2 by 4. Isn't it? We know that. We learned it in fractions. So that's the same thing that we're doing here. You can write it as y by b or minus b by a. Sorry, y by a minus b by a. Like this also you can write. Or you can write it this way also. But basically, A should be divided for both the Y and B. That is what is you have to remember. So that's done. Then what are we doing here? A into x square by A. So A goes off, right? A goes off. So A gets divided. A divided by A is 1. Now we have got this much. X square is equal to y minus b by a. Now we have that operation called squaring. We'll have to nullify that, means opposite is square root of it. So I'm going to take a square root of the left side thing. Now again, square root of the entire thing you have to do. That gives us square root of x square will be x itself. It would have nullified the effect. Don't think you're cancelling. No cancelling. It's this when you do such things, you are not actually talking in mathematical terms. It is not cancelling. Cancellation doesn't happen like that. No, it doesn't happen for a square root and square. The effect gets nullified. Why it gets nullified, you can watch in my other videos where I'm talking about surds. There also you can learn about how the square and square root gets nullified, right? When you are putting on the same number. Okay, so now we have got for this also. Okay, now I think you've got a hang of it. Now I'll not be explaining every step how we are doing it. I'll be just saying what is the steps, and I would highly recommend that you pause the video here and do all these problems on your own, and then come back to the video and check whether the answers of mine and yours are matching. Now, why I say this is because math is not learned by just listening or seeing the solutions of somebody solving it. You do not learn maths that way. You learn maths only by you thinking and solving it. Of course, pause the video, solve it, and then come back to the video and watch whether your steps and the answers were right. If it is not right, see why it is not right and learn that way. That is the best way to learn. Okay. So here the outermost operation in this question is addition. So I'm going to do subtraction y minus b. So I'm not going to write the entire thing that basically, yeah, plus b minus b is there. But I'm not going to write it because I have nullified it, I know. I have not, it's not that B is getting transferred here and all, nothing like that. But I have nullified the effect of plus B with a minus B. So it gets nullified. It is not at all there anymore. The next, the outermost operation here on this is root. So I'm going to use opposite operation, that is square. Now if you see, I'm squaring for the entire y minus b, because when you're doing it, it should be done for the entire left side, entire right side. The square root and the square gets nullified, nullified with each other. Now I'm left with a multiplication operation which is there. So I'm going to use the division operation to nullify the effect of multiplication with a. So y minus b the whole square, and I have to again divide to the whole thing. I'm dividing it, so I'm getting a x here. So this is my answer. This is why I have manipulated it. This is how I manipulated it. Okay. Coming to the next thing here, the outermost operation here is a square root. If you see here, x is there inside. Okay. But then my x is multiplied here and then added with b and then done a square root. Correct? So the outermost, the last operation is a square root. So opposite to that is a squaring. So I am squaring it. So what happens? That entire operation of square root goes off. And I get this. Now, what is the next outermost operation? Is it the multiplication or the addition? If you want to understand which is the outermost operation, you just read A is multiplied with X and then added with B. You see, when you read it, you know, oh, and then it is added with B. And then it is added with B. So addition is the outermost operation. I'm going to nullify it by using subtraction of it. So that entire plus B goes off. So I'm getting this. Now here the final operation is multiplication, which I'm going to do division. So y square minus b entirely divided by a is equal to x. So that's my answer. Coming to the next one. Now here if you see the outermost operation, if you are again confused, read out. X is squared and then added with b and then later divided by a. Correct? If it is like this, how would you read it? X is squared and divided by a and then added with b. If you see here, the final operation was a division. Here, when I read it out, the final operation was addition. See, can you see when you read out, you understand that what is the final operation. And we know that we have to remove the final operation. We have to remove the final operation. So, okay, let's remove the final operation. That is, A is divided, right? So, opposite of the division will be multiplication. So, I'll multiply with the entire left side with A. And so, because of that, what will happen? It'll get nullified. Now, as I was telling the second step, always there should be a connection between the steps, right? Now, if you just think and see, from this step, can I get this step? Yeah, by dividing A. If I divide A here and also divide A here, what will happen? A and A will get divided. A divided by A is 1. See, look, I'm getting the previous step, right? So, this is how I was saying that there should be a connection between the steps. Okay? So, every time when you're doing it, check whether you're getting the previous step by doing the opposite operation. Okay, now we have done this. Now here the outermost operation is addition. So I'm going to subtract it. I'm going to subtract it and then I'm going to nullify that addition of b and I'm left with x square. Now the operation is squaring. The opposite of that squaring is square root of the entire thing. See, it's very important to do for the entire thing and I get a x. So that's my answer. I got x is equal to. That's what my final thing I wanted. Now coming to this question. Now what is the outermost operation? To understand this again, x is divided by a and then done a square root, then added with b. So the outermost operation is addition. So I'm nullifying it by subtraction, which leaves me with x by root of x by a. Now the outermost operation is what? Square root. So I will do the squaring. Now squaring has to be done not separately like this. It's not right. You have to do it for the entire thing. So remember, x square minus y square is not same as x minus b the whole square. It's not same. Remember, this is not same as y square minus b square. No, it is not same. Remember, y minus b the whole square is actually equal to y square minus 2yb plus b square. This is actual equation, actual way, actual thing, it is correct. Okay. So remember, if you are doing a square, don't do only for one thing and then subtraction another thing. Remember, it has to be done for entirely, not only for squaring. Let it be, you are doing it with addition or subtraction. You're doing for the entire left side, entire right side. You cannot do for one thing separately. Now, if I am doing, for example, if I'm doing subtraction, why is it that I did only, one side? If you say, for example, let's say, take from this step to this step. You would ask me that you did not do entire thing here. No, I did. Because you see, after multiplication, I am doing the subtraction. That means Entirely I am doing. I am not doing y minus b first, okay, and then multiply by a. No, no, no. Multiply by a, that is become a one unit now. And with that one unit, I'm subtracting. Similarly, y minus b has become one unit now. And for that entire unit, I should be doing the squaring. So I will be doing the squaring. I will get the entire unit squaring. I'll get like this, which I'll give the right side with after a nullified effect of I will retain x by a. Now there's a division of a. So I'm going to multiply it for the entire thing. That means a is multiplied with y minus b the whole square. That will be equal to x. The effect of nullification, effect of divided by a is removed. So my answer is this. So if you have stopped the video in the middle and done your equations and you've got it right, all of them you've got it right, congratulations, you've understood manipulation, and this skill is going to be helpful for you for entire lifetime. And this is how math prepares you for life. I hope you enjoyed this video as well as you understood how math helps you for life, how even the absurd looking algebra is useful in your life.